Hello, ladies and gentlemen, this is Mrs. Gallagher, and today's objective is to use systems of linear equations in the real world. So systems of linear equations can be used to model and solve real-world problems such as fees and purchases. So we are going to model and solve real-world problems with examples such as fees and purchases. You can solve systems of linear equations using a graph, substitution, or elimination. So we can solve a system of linear equations using a graph, substitution, or elimination. The best method to use depends partly on how the given equations are written. So if we look at the table below, it has methods of solving systems of equations. And here's our method here and when to use the method. So whenever we have a visual display or you want to estimate a solution, the best method to use is our graphing method. So we use our graphing method whenever we have a visual display or estimating a solution. When you want to estimate a solution for one of its variables, and when it's easy to solve for one of the variables, we're going to use substitution. So we want to estimate a solution for one of its variables, and when it's easy to solve for one of the variables, we're going to use the substitution method. When the coefficients of one variable are the same, or the additive inverse, we're going to use elimination. So when your coefficients of one variable are the same or the additive inverse, we're going to use elimination. Okay, so these are our methods. Now let's discuss the steps to solve systems of equations using word problems. So step one, when solving a system of equations using word problems, we want to first define variables. So step one, define your variables. Step two, you want to write the system of equations. So in step two, we're going to write the system of equations. And you have two equations with a system of equations. Step three, decide which method works best. So in step three, you want to decide which method works best. Typically with word problems, we're going to be using the elimination method and the substitution method. And our last step, step four, solve for the variables. Remember, you want to solve for x and y. You have two variables to solve for. So in step four, solve for the variables, x and y. Okay, we have two variables you have to solve for. So now let's do some examples together after discussing the steps. So let's look at example one. It says, write and solve a system of equations for the following word problems. At a recreation and sports facility, 3 members and 3 non-members pay a total of $180 to take an aerobics class. A group of 5 members and 3 non-members pay $210 to take the aerobics class. How much does it cost members and non-members to take an aerobics class? So let's first define our variables. So what are we talking about here? We are talking about our members, and we are talking about our non-members. So let's have M stand for members and N stand for non-members. So our M stands for our members and our N stands for our non-members. So let's make our first equation up. At the recreational sports facility, we have 3 members. So how many members? We have 3. So 3M and 3 non-members. It says, and 3 non-members. So we're going to add that. We're going to add that to 3N. That pay a total of $180. So therefore, it's going to equal 180. So that's our first system of equation. That's step 2. Now our second system, it says here, a group of 5 members. So we have 5 members. That's 5M. And a group of 3 non-members. So you're going to add 3 non-members, 3N, pay $210. So that equals 210. So now we have our systems of equation. Now I have to figure out what is the best method for this system. And what you notice here is you have a same coefficient, and the same variable. So you want to use the elimination method with subtraction. We're going to use elimination using subtraction method. So let's do that. We want to put our negative in front, and we're going to rewrite the top. 3m plus 3n equals 180. And you want to distribute on the bottom the negative to each term in this equation. So we have negative 5m minus, because a negative and a positive give you a negative 3n, and that's going to equal a negative 210, because the negative is being distributed. And now we can solve. So our first step here is to cancel out the 3n's. And now we have 3m minus 5m is negative 2m equals 180 minus 210 is going to give us a negative 30. Divide both sides by negative 2. And m equals 15. So it's $15 for members. M stands for member, so it's $15. Now let's find the non-member. So again, we're going to use either equation. We use the first equation. So we have 3m plus 3n equals 180. We're going to substitute our m because we found the members, which equals 15 plus 3n equals 180. 3 times 15 is 45 plus 3n, or non-members, equals 180. Your next step is to subtract 45 from each side. 45's cancel. And left with 3n equals 180 minus 45 gives us 135. Last step is divide by 3. So n equals, for non-members, $45. And that is your answer. So let's put it up here. We have members equals $15. And our non-members, or n, is equal to $45. And that is your answer. Let's do another example together. Okay, so number 2. One car model costs $12,000 and costs an average of 10 cents per mile to maintain. Another car model costs $14,000 and costs an average of 8 cents per mile to maintain. If one of each model is driven the same number of miles, after how many miles would the total cost be the same? What is the total cost? So our first step we want to do is define our variables. What are we looking for here? Well, we're looking for the number of miles and the total cost. So let's have x equal the number of miles, and we'll have y equal the total cost. So let's write our equation for car 1. It says car 1 model costs $12,000 and they cost an average of 10 cents per mile. So we have car 1 and our total cost, y, equals, we know it's $12,000 plus 10 cents per mile. So we'll do 0.10 and x is our miles. That's in car 1. The other model, car 2, costs $14,000 and an average of 8 cents per mile. So we have car 2. And we know our total cost, our y, equals 14,000 plus 0.08x. So now we're going to think to ourselves, after we just wrote our system of equation, which method should we use? We should use substitution by setting them equal to each other because they're both equal to y. Y equals y. So we're going to use substitution by setting the equations equal to each other. So since they both equal y, because y equals y. We're going to replace it with 12,000 plus 0.10x equals 14,000 plus 0.08x. Next step is to get rid of the smaller variable. So we're going to subtract 0.08x from each side. These cancel. So we have 12,000 plus 0.02x equals 14,000. Next step, subtract 12,000. So we're left with 0.02x equals 2,000, and the 12,000s cancel. And then our last step is to divide by 0.02 on both sides. 2,000 divided by 0.02, you're going to get x equals 100,000 miles. So we found our miles, we found our x. Now we want to find our total cost. So we're going to pick either equation. I'm going to pick the first one. Y equals 12,000 plus 0.10x. All right, so y is our total, 12,000 plus 0.10, and we're going to substitute our miles, which was 100,000 miles. So now we have y equals, and you're going to multiply 0.10 times 100,000, which gives you 10,000. And our last step is to add. So we have y equals, our total cost is $22,000. So now that we solved, we can define our x value is equal to, our number of miles is 100,000. And our cost, our y value, is equal to 22,000. Okay, let's do one more example together. All right, let's look at example 3. Jose bought 9 movie tickets for a total of $54. Adult tickets cost $8 each, and child tickets cost $3.50 each. How many adult tickets did he buy? How many children's tickets did he buy? So let's first identify and define our variables. We have adult tickets, so we'll have our adult tickets are our x value. So our x value is the adult cost, and our y value we're talking about is the children's cost per ticket. So y is the children's cost. So y is the children's cost. So now we're going to set up a system of equations. So what do we know here? We know he bought a total of 9 tickets. But we don't know how many of each. So we know we have x for adult plus y for children equals 9 total. We also know the cost per ticket. So we know the adult cost is $8. So that's to be 8x plus our children's cost is $3.50 each. So $3.50 y, and the total cost is going to be $54. So it equals 54. And how much does each ticket cost? So what method are we going to use here? Well, we're going to use elimination using multiplication. We're going to turn this into a -8 on the top system. So we use elimination by multiplication. So now we're going to multiply our top equation by -8, and we're going to distribute -8 to each term in the equation. So now let's multiply. -8 times x is -8x. Then a -8 times a positive y gives us a -8y. And that equals -8 times 9 is -72. And let's rewrite the bottom. 8x plus 350y equals 54. Now we can eliminate the 8x's. So negative 8 plus 350y is negative 450y. And that equals negative 72 plus 54 is negative 18. Divide both sides by negative $4.50. And y equals $4. So your cost of a child's ticket is $4. And let's put that right up here. $4. So now that we found the child's ticket, let's find the adult. And let's use our original equation. X plus y equals 9. And we just solve for our child's ticket. So we have x plus our y value is 4. And that equals 9. Our next step, we're going to subtract 4 from each side. And we're left with x equals 9 minus 4 is $5. So your adult ticket is equal to $5. And we'll put it right up here with adult. And that is $5. So now what I'd like you to do next is the you try section. Please complete problems 1 and 2, and we will discuss them in class together. Thank you.